Good morning, sir. This is Bomineni Kavya from AI. Today, I would like to discuss few problems based on differential equations. So, let's see our first question, which is given as find the following for the f of x equals to x power 4 minus 2x square plus 3. And first, to find the critical points of f and increasing decreasing intervals, and also to find the local minimum and local maximum, and also to find the concavity and the inflection points. So, let's find first the critical points of f. So first, let's find the first derivative of f of x, which is 4x cube minus 4x, and on taking this on equating this equation, we get x values are x equals to 0, 1 and minus 1. Hence the critical points of f of x are x equals to 0, x equals to 1 and x equals to minus 1. So let's next find the intervals, whether the f is increasing or decreasing. So let's take our first interval as minus infinity less than x minus less than minus 1. On substituting a value between this interval, we get a negative value, which shows that it is decreasing, and the second interval is minus 1 less than x less than 0. On substituting the values between this, we get a positive value, which shows that the function is increasing, and the third interval is 0 less than x less than 1, on which it shows that the substituting the values between this, the f is decreasing function, and the last interval is 1 less than x less than infinity, on where substituting the values between this shows a positive value, which shows that it's a increasing function. So next, let's find the local maximum and local minimum. From the first derivative test tells us that there is a local minimum of x where x equals to plus or minus 1. On substituting a value plus or minus 1, we got uh, uh, final answer as 2. And there is a local maximum value of x at x equals to 0. On substituting the value, we get x equals f of 0 is equals to 0. And next, let's find our next one is where to find the concavity and the inflection points. So let's find the f double dash of x, which is 12x square minus 4. On equating this, we get x equals to plus or minus 1 by root 3. Let's find the intervals, which is minus infinity less than x less than minus 1 by root 3. On substituting the values between this interval, we get a positive value, which shows that it is concave up. And let's see the next interval, which is minus 1 by root 3 less than x less than 1 by root 3. On substituting the values between this, we get a negative value, which shows it is a concave down. And the last interval is 1 by root 3 less than x less than infinity. On substituting value between this interval, we get a positive value, which shows it's a concave up. And inflection points, we get plus or minus 1 by root 3 comma 22 by 9. On substituting on taking plus 1 by root 3 and minus 1 by root 3, we get the inflection points. And the second question is guess the value of limit x tends to 0 sin x by x, and hence we can let f of x be sin x by x. On taking x values plus or minus 1 plus or minus 1 plus or minus 0.5 plus or minus 0.4 plus or minus 0.3 plus or minus 0.2, respective f of x values becomes given in the table, and from the above table we can find out that limit x tends to 0 f of x is equals to 1. And the third question is sketch the graph of the function, where the function is 1 plus x, where x is less than minus 1 x square, where the interval is minus 1 less than or equals to x less than or equals to 1, and 2 minus x where x is greater than or equals to 1, and use it to determine the values of a for which limit x tends to a f of x exists. On taking the first function, which is 1 plus x is less than or minus 1, on substituting the values between this interval, let's assume that minus 2 minus 3 and minus 4 are the values, hence we get the f of x values are minus 1 minus 2 minus 3. And second interval is x square, on where the interval given is minus 1 less than or infinity less than or equals to x and less than or equals to 1. Taking the values between this as minus 1 0 1, we get the respective f of x values as 1 0 and 1. And the last interval on the last function is 2 minus x square, which is where x is greater than or equals to 1. We get let's take our values as 1 2 3 4, where f of x values goes to 1 0 minus 1 and minus 2. And on plotting the graph, we get as below graph, and taking x equals to minus 1 and substituting the f of minus 1, which shows that the left side of the minus 1 values, we get it as answer as 0. And for the f of minus 1 values, we get the answer as 1. And for f of minus 1 plus, which shows that the right side values of 1, and substituting this, we get f of minus 1 minus is not equals to f of minus 1 is equals to f of minus 1 plus. F is discontinuous at x equals to minus 1. And where x is equals to 1, on finding the f of 1 minus, which shows the left side values of 1, we get answer as 1, and substituting f of 1 we get answer as 1, and substituting f of 1 plus, which tells that right side values of 1 also gives us the 1. Here we can see that f of 1 minus equals to f of 1 equals to f of 1 plus, hence we can say that f is continuous at x equals to 1. Hence limit x tends to f of x exists for all a except a equals to minus 1. And let's see our last question, which is given as sketch the graph of the function f of x equals to 1 plus sin x if x is less than 0, cos x if 0 is less than or equals to 1, 0 which is less than or equals to pi, and sin x if x is greater than pi, and use it to determine the value of f of which limit x tends to f of x exists. And let's see for our first function, which is 1 plus sin x, where x is less than 0. Let's take values as minus pi by 2 minus pi, we get f of x values as 0 1. And let's take our next function cos x, limits to 0 less than or x less than pi, 0 pi by 2 pi, and sin x less than sin x where x value is greater than pi. Let's take the values as 3 pi by 2 and 2 pi, we get the respective f of x values. From the graph it is noticed that limit x tends to f of x exists for all a except at a equals to pi. Since limit x tends to pi minus f of x is not equals to limit x tends to f of x x tends to pi plus, and we get the graph as the shown. Thank you, sir.